Okay, so what we're going to do today is try and attach this load cell through a Wheatstone bridge to our Arduino board here on our Turbidostat bioreactors. So what we're going to need to do is actually solder these 4 wires to the Wheatstone bridge and then solder another 4 wires that can be connected into our actual Arduino. So what we've done here now is we've soldered the red, black, white, and green from the load cell onto the E+, E-, A-, and A+ connectors. And now we need to connect the other side to our other wires that will connect to the Arduino. Okay, so here we've connected the VOC, SCK, DT, and ground to a red, purple, blue, and black wire that we will use to do the following connections to actually connect to the Arduino board over here. Okay, so what we're going to do today is we're going to integrate 2 different components of our Turbidostat reactor into one. What we have is the Turbidostat reactor over here. It has our pump and our pump controller and various different pieces that actually operate the Turbidostat that we'll go through here as I integrate these together. And we have this balance here that now is going to be communicating with the Arduino board that's on the back of the Turbidostat bioreactor. What I'm going to do is actually, instead of having these be 2 separate pieces, I'm going to mount them together using a new base plate that we've printed out here that actually has the capability of actually screwing the 2 components together into one component. So basically take the bottom part of this balance and take the actual metal pieces and attach that to this new base plate, and also bring over our mixer, which is just a simple computer fan with a magnet attached to it, and then bring over the components to the pump over here as well to integrate this, so that we basically have one reactor that can be moved in one piece. So this is just the metal plate that we're going to use to actually attach the load cell to this base plate, this plastic base plate for our balance. We have to use the metal piece here so that the plastic doesn't deform on us when we actually put a load on the load cell. It's a 5 kilogram load cell, so it has to be able to handle a little bit of weight because we're going to have 1 liter of water sitting on top of this in a media bottle, and so we use this as the base. It has some pre-screwed holes here that we can, or pre-drilled holes here that we can actually run our screws through to mount the plate and mount the load cell to all this. So I'm going to do that now. Okay, so now we've inserted that base plate, the metal base plate here, into the actual plastic base plate that'll kind of house the balance on top of that. We've also gone ahead and attached 2 screws here. These screws are number 8 by 3/4 inch pan head screws, and there's another hole here that we'll attach after we actually get the balance and everything back in that we'll attach now. What we've got now that's attached, we've got 1 single component just so that the wires don't get pulled out if these accidentally get moved around while we're handling the Turbidostat reactor. Alright, so what we're going to do now is go ahead and move this fan that serves as our mixer, our stir plate. We're going to transfer that from the older reactor over to our new base plate here for the Turbidostat. So we're going to transfer that first. Alright, so our fan is going to be attached with these number 4 oval head screws that we have here. It looks like they're about maybe a 1/2 inch to 5/8 of an inch. So now that our fan is attached here, that gets attached to a 5-volt positive and our ground here. Just attach that through. Again, this is just a simple computer fan that we have here that we've purchased. That's what's going to actually have this plastic part that has a couple of super magnets in it that, when this is spinning, serves as our mixing device for our stir plate for our reactor. So at this point we're going to actually remove the peristaltic pump motor from the actual device that actually powers the motor. We need to remove those wires up there so we can pull the motor out and transfer it over to our new chassis. The wires here are attached from left to right on the top as a green, black, blue, and red. So we'll reattach that, but to get the motor out we actually have to detach those wires first. Alright, Alright, so now we're going to take the motor, attach it to the new chassis here. The screws here, again, these number 4 oval head type screws. Looks like they are, again, probably about a 5/8 to a 3/4 inch screw here. Alright, so we have the motor now attached to the new plate here, or the new chassis. We just need to remove the power supply and the power supply here and the actual power source board here that will attach and communicate with the Arduino on the back of the reactor. So we just have to remove these 4 screws, then reattach those original 4 wires again, and then attach everything back up to the board and start connecting this back to the rest of the components. Alright, so we now have our power supply connector here reattached to the board. This is attached again through some of these number 4 by probably about a 1/2 inch pan head screws. I've reattached the wires down here to the actual controller board. You can see that the main red power off of the inlet power here for the connector to the power supply is going into the red here. The black wire is going to our ground again. And then our brown wire is attached through a resistor to the actual Arduino board over here, as is the orange wire. Those are the 2 pieces that control the amount of power that goes to the board to control how fast the pump runs, and also triggers the board or the motor itself to run. So everything's there. We now have our empty chassis over here from our previous design, and now our chassis is attached to the plate here for our actual balance to be connected. So we're just going to reattach the Turbidostat top components to this, and then we will start connecting up the balance. Alright, so our actual housing here that we use to actually insert our reactor that will be used to actually measure density over time. That gets inserted here, and we actually have some of these number 8 by 3/4 inch pan head screws that we actually attach through these 4 different posts to the bottom chassis, so that now the secondary or middle component is attached to the reactor. The only other thing now to do is reattach the actual load cell over here and go ahead and put the Wheatstone bridge back in this little compartment. We'll do that before we actually attach the bottom plate here to the reactor to complete that. Alright, so our Wheatstone bridge is now safely tucked away here underneath this plate, so it'll be protected. Wires coming out one side that are attached to the actual load cell here, and the other side can be attached to the Arduino when we actually have the last of the load cell kind of hooked up. Alright, what we can see now is we've got our load cell attached to this plate here. Again, we have to have a steel plate so we don't get deformation of the plastic on the top, and we have some spacers on either of those that we connect everything to. And this is connected through the bottom here on the little brace that we are, the mounting bracket that we have. It's also inserted. So with that, we now have all the components integrated into one complete piece, so they're kind of together. This serves as our balance to actually measure our liquid levels of our media that we'll be loading into the Turbidostat. We just need to hook everything up to the Arduino board here again, so that we can actually use that to control the reactor when it's running. Alright, so we now have our Wheatstone bridge wires. Our purple and blue are attached over here to slots 7 and 6 off the Arduino board. The black wire here is gone over to our ground, which is on a shared loop here on the breadboard. And our red wire is attached to our 5-volt, which is also on our breadboard here. So the balance is now connected up to the Arduino, so the Arduino can control that. And our power supply for the pump is also reapplied to reattached to the Arduino. That is running with the orange wire off of bank number 5 and the brown wire off bank number 2. It's important that that brown wire actually have a resistor, so we have a resistor in line with that to control that. And so our Arduino board now has control of the balance, or the load cell here, so that it can actually take the load cell and take the weight that it's measuring off of that and convert that into a value here. And it also is able to have control of the actual motor over here that will run the pump to actually deliver more liquid into that. Everything else is attached, so we have power to run the motor. The rest of the power for the Arduino comes from the computer, which will get attached here on the Arduino. Alright, so now with everything integrated, we can go ahead and hook up the reactor to a computer. The software has already been downloaded to this, so we just need to come in here and attach the Arduino to our computer. That should signal the LED lights on the inside to go ahead and start going through their cycle, where they actually flash, and then that gets recorded over here by this board that has a light sensor attached to it, which will actually take the light data with the lights flashing and without and do a background calculation. And then based upon whether something is inside of here, a bottle of media, and how much light is being blocked by the culture that's in there, that will take an optical density measurement, or some sort of optical density measurement, which we can use to actually measure our density of our culture, so that we have that feedback that's going to be controlled through the actual Arduino board. And the program basically will run that light sensor about every minute or so, just to kind of take a measurement, and then based upon that, we'll run the pump when it needs to be diluted. The media bottle gets put inside of there, and it gets put inside a housing so that we can minimize any background light. This is where the top of that media bottle will sit in the reactor.